Bismillahirrahmanirrahim. This chapter is all about triangles and congruent triangles, to be precise. So the first thing we have to understand is what does it mean if two triangles are congruent. Although we'll be primarily talking about triangles, we can talk about congruent figures or congruent polygons in general. So what does it mean for two figures or two polygons or two triangles to be congruent? That's the first thing that we must appreciate. For any two figures to be congruent, two things have to occur. The first thing that has to happen is that all the corresponding parts have to be congruent. All the corresponding sides, corresponding, all the corresponding sides have to be congruent. And that's very, very important to understand. So for two triangles to be congruent, two quadrilaterals, pentagons, or whatever have to be congruent, all the corresponding sides have to be congruent. And all the corresponding angles have to be congruent. That's the second criteria, is that all the corresponding angles have to be congruent. Now, what do we mean by corresponding? That's the key thing that we have to appreciate. Corresponding means matching, right? So it's like the angles have to match and the sides have to match. So if two figures are congruent, then all the corresponding sides and all the corresponding angles are congruent. And the concept of being congruent figures means that you can take one figure and put it right on top of the other figure or superimpose it, kind of like Lego pieces that fit right on top of each other perfectly. So two congruent figures are figures that can be superimposed and put on top of each other, and they would match perfectly. So for two figures to be congruent, they have to have all the sides, all the corresponding sides have to be congruent, and all the corresponding angles have to be congruent. And this you must understand and memorize. So two criteria have to be satisfied for figures to be congruent. All the sides have to be congruent, and all the angles, not just any sides and any angles, but the corresponding ones, they're matching ones. Okay, and if two figures are congruent, they just fit right on top of each other in a way. It's like identical figures in that sense. So here, for example, we have two triangles here, and the statement here says triangle ABC is congruent to triangle HJK. So we have triangle ABC, and we are told that this triangle is congruent to this other triangle, triangle H, J, and K. Now, the order of how these alphabets are is very important. In other words, when we say a statement like this, triangle ABC is congruent to triangle HJK, what we're saying is angle A is congruent to angle H, and angle B is congruent to angle J, and angle C is congruent to angle K. So that's actually very, very, very important. So triangle ABC congruent to this triangle means angle A is congruent to angle H. So you can mark these like this. So these two are congruent. And then second in the list of alphabets, ABC, is the B, which means B corresponds to J. So angle B is congruent to angle J. And finally, C corresponds to K. So we can say angle C is congruent to angle K like this. So the order makes a difference. Now, ABC is congruent to triangle ABC is congruent to triangle HJK, means A is congruent to H, B is congruent to J, and C is congruent to K. Now, observe, there are different ways of naming triangles. I could have named this particular triangle, for example, as triangle JKH. JKH. You could name the triangle with different names, but it would be wrong to say that triangle ABC is congruent to triangle JKH. That's just not true, because J is not congruent to A. J is congruent to B. So the order of how the alphabets are written makes a very, very big difference. So triangle ABC is congruent to triangle HJK, and that's a precise statement. Triangle ABC has to be written in this way. Now you can write, on the other hand, the triangle BCA, starting from B and going like this. And that is indeed congruent to triangle JKH, because in this case the corresponding angles are going to be the same. B goes with J, and C goes with K, and A goes with H. That would be a correct statement. So you have to match the correct angles and the correct sides, the corresponding angles. So when two triangles are congruent, all their corresponding angles are congruent, all the corresponding sides are congruent. Now, what this also means that side AB is going to be congruent to side HJ, and side BC is going to be congruent to side JK, and side AC over here is going to be congruent to side HK or KH. Okay, so these are corresponding sides and corresponding angles. All right, so when two triangles are congruent, all their corresponding sides and corresponding angles are congruent. The first thing we have to therefore understand is to interpret this particular statement correctly. And what that means is we have to understand which figures, which angles go with which angles. So the first thing to do is figure out where you're starting. You're starting with angle A. So I just tend to circle that angle. It's angle A right here. And over here, mark also where you're starting. Here, we're starting with angle H. So I mark angle H right there. And then I put a little arrow to let me know which way I'm going. I'm going from A, B, C. So I'm going from A, and the next angle I'll visit will be B. Here, I'm starting with H, and the next angle I'll visit will be J. So I'm starting like this. So now I know in which direction I'm going to go when I'm going across this triangle. So triangle ABC is congruent to triangle HJK like this. Now I know I can't make mistakes because it's important to know where you're starting and in which direction you're going, so you can match. So you can match the sides and you can match the angles. Okay, so it's very important to keep those in correct perspective. So once you know ABC, you can say from A to B, okay, that's going to be congruent to H to K. That's the first side you meet. This is the second side you meet, so that's going to be congruent to this. And that's the third side you meet if you go across like that. And that's going to be congruent to that. And in the same way, starting with A, that's congruent to H. The second angle is this one. And the third angle is this one over here, like this. So you can mark them very easily. So when you're given information like this, the first thing to do, the very first thing to do, I have to emphasize this right here, is figure out the starting point. The starting point is angle A here and angle H here. And then also figure out in which direction you're traveling. A, B, C means you're going like this. And here you're going H, J, K, and you're going like that. So it's very important to figure out where you're starting and in which direction you are traveling to make sure that you get all the corresponding sides and corresponding angles correctly. Okay, so now here we have two triangles, and triangle ABC here, and this other triangle, and it's already marked for us. And so here we're going to write down, how do we write that these two triangles are congruent? Well, here's ABC. So you can see here A corresponds to X, right? Because they're congruent. As you can see, they're marked by the same symbol. So these tick marks here that suggest the angles are congruent, and these tick marks here that suggest the sides are congruent, that's how we figure out how they are congruent, see? So in this case, you can see all the sides, all the corresponding sides are congruent, and all the corresponding angles are congruent, okay? So so we can say triangle A, let's say triangle ABC, so starting with ABC, and you can say that's X, and B here is M. B corresponds with M because the two tick marks are there for the angle, and C corresponds with P. So we can say then triangle ABC is congruent to triangle XMP like this, can't we? Now it would also be correct, it would be perfectly all right to say triangle, it's a funky looking triangle symbol, I'm trying, triangle CBA is congruent enough to go figure out which one corresponds with C. Well, C is P, right? That's going to be congruent with triangle P, and then B corresponds with M, and then X, like this. So this would also be correct. Triangle ABC is congruent to XMP, ABC is congruent to XMP, and triangle CBA here is congruent to PMB. These are both correct ways of writing this because all the corresponding angles are in perfect order. A corresponds with X, B corresponds with M, and C corresponds with P. Correct? So in this case, C corresponds with P, B corresponds with M, and A corresponds with X, again like that. So this would be both correct ways of writing that these two triangles are congruent. Now, as I said, you can have triangles congruent, you can have any polygons that are congruent. Right? So I've drawn here a quadrilateral, and we are told that this particular figure ABCD, is congruent to WXYZ. So these two figures are congruent, and the vertices are labeled for us. Now we're given a whole bunch of information about this particular triangle. Now we have to find the corresponding angles and sides in the other quadrilateral that's given to us. For example, if we're told that this is 90 degrees, so which one of these angles is 90 degrees in the other quadrilateral? And here we're given that's 45 degrees, so which one of these angles is 45 degrees? If they are congruent figures, then the corresponding or matching angles have to be congruent, and the corresponding or matching sides have to be congruent. So which is the matching side for 4? Which is the matching side for 8? So that's what we have to figure out over here. As I suggested, the first thing I do is then, which I found very helpful, is to identify where you're starting out with and in which direction you're going. So here I'm starting with A, so angle A, so here's A, and I'm going in ABCD. So I'm starting with A, and I'm going and tracing this particular quadrilateral in this direction. So ABCD. And the angle that matches or with A is W, so here's W. And I'm going in WXYZ direction, so I'm going in this direction, so like here. So I'm going to go like this way around in this particular quadrilateral. So now I have the matching starting points, and I have the matching directions in which I'm traveling, right? So then it becomes very easy, see? Then I can say, well, if A is the starting point and W is the starting point over here, then these angles match, so the angle W has to be 45 degrees. All right, so 45 degrees, and I'm traveling this way. The next angle I reach is going to be side B over here, and that's X, and we're given 90 degrees, so okay, so this is going to be like 90 degrees because the corresponding angles are congruent. And then if you were, and then here we're at B, and then if you were to keep going this way, you come across C, that's going to be Y over here. And this side length we don't know about much over here like that, right? So so A, B, C, D, right? So we can say AB is congruent to this, so we can write that. Okay, BC is 2 tick marks, and that's like this. And the CD here is 3 tick marks, so we can write those 3 tick marks. And finally, this 4th tick mark is going to be like, you can put different symbols. Let's put that symbol over here, because 4 tick marks becomes kind of hard to count after a while. So those are congruent. Now, so we know, okay, we don't know what the length of these 2 tick marks are, but we know what 3 tick marks are. 3 tick marks are 4, so this side is 4. And then this circular tick mark over here is 8, so we know this side is 8. So we were able to identify all sides. Now you can see how easy it is if you identify the starting point and the direction, because if you know the starting point, you can start putting all them tick marks, and then you know which one corresponds with which. I was kind of getting confused if I didn't put the tick marks, which side goes where. So if you're that way, just mark the tick marks so you know which side 1, 2, 3, 4 goes with which, and then it becomes very easy to put the numbers with the tick marks like that. Okay, so you can have congruent triangles, and you can also have congruent quadrilaterals, pentagon, hexagons, or any particular quadrilateral. Okay. All right, so here is our next example. So first, let's just review congruent triangles. So for 2 triangles or any 2 figures to be congruent, we understand that all the corresponding sides are congruent, and the second thing we learned is that all the corresponding angles are congruent. Another way of saying that is something we call very affectionately CPC and you got to know this. It's like the geometry, like, you know, thing. Corresponding parts of congruent triangles are congruent. So that's what this stands for. Corresponding parts of congruent triangles are congruent. CPCTC, because that's like an abbreviated version of what it means to be congruent triangles. So CPCTC, and it even sounds cool. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Now, parts means sides, parts means angles. So this is true for any polygon, but we mostly deal with triangles. So we use CPCTC a lot for triangles. Corresponding parts of congruent triangles are congruent. That's what that means. It'll save us some words. Okay, now we have two triangles, and we're told here that triangle ABC is congruent to triangle DFE. All right, so if that's the case, the starting point is A, and we're going in this direction, ABC. That's very, very important. So starting point is A, and we're going in the direction of ABC. So here's A, and we're going in this direction, and DFE, so DFE. So that in this case, they made it easy for us. The starting point, they look very similar and like this. So then we know that A is congruent to D, B's F, and C goes with E. That's the corresponding parts of congruent triangles being congruent. Now D is going to be 45 degrees because it corresponds with A, and corresponding parts of congruent triangles are congruent. So D is congruent to A because of CPCTC. Same way, F is equal to 99 degrees because of CPCTC. Corresponding parts of congruent triangles are congruent. In the same way, angle E here is going to be 36 degrees because the corresponding parts of congruent triangles are congruent. Now here we're asked to solve for x and y. So the question is asking us to solve for x and y. So here we have it. Now this here is the angle that corresponds to the 99 degrees. So now we can solve for y pretty easily here, right? So, okay, so let's come up with that equation. So we have 8y minus 5 is equal to 99 degrees. How do we know that? That's because angle F corresponds with B, and CPCTC, corresponding parts of congruent triangles, are congruent, right? Now, you can solve this, and you can get 8y and add 5 to both sides. You get 104, and you divide both sides by 8, and you get y is equal to 13. Here we got it. So we found y. Well, we're supposed to solve for x also, but we know that this side corresponds with this side over here, right? So we can write this equation here. Watch. So 2y plus x is equal to 38.4. Now we just found out y. Now y is 13. You substitute that over here in place of y. So you get 2 times the y, which was from over here 13, and then plus 8 is equal to 38.4. 38.4. How do we know this side is 38.4? Because CPCTC, corresponding parts of congruent triangles, are congruent. So that's 2 times 13 is 26. Last time I checked. Sorry, where did I get 8? Plus x. I'm sorry, I made a mistake over here. That's, suppose you didn't correct me. Okay, so here's x. Here's x over here. Equals, so 26 plus x is equal to 38.4. Subtracting 26 from both sides, I get 2.4. So 4, 26, 2, 1. So that's it. So we got it. So we solve for x and we solve for y. So here we learned a new term, an easier way of saying A goes with D, etc. CPCTC, corresponding parts of congruent triangles are congruent. Let's see what we have next. Okay, next we are introduced to a new theorem in this section, and it's a very easy theorem, very intuitive theorem actually. So, and the theorem is called the third angle theorem. Third angle theorem. It says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. That's pretty easy. It says if this angle is congruent to this angle and this angle is congruent to this angle, then the third angle here is congruent to the third angle over there. That's pretty easy, right? And it's kind of intuitive, right? If two of them are congruent and they add up to be congruent and subtract from 180 degrees, it's going to be congruent. So if two angles of one triangle are congruent to two angles of the second triangle, then their third angles are congruent. In this case, angle A would be congruent to angle L over here. So we can mark that over here like this. So this is the easy peasy third angle theorem. Okay, so we have two questions to do, which are actually proof questions to finish the section. So here's the first question. It's a proof. So we're given the following. We're told that DE is congruent to GE. So as soon as you know that something is congruent, you might as well mark it. You know, it's going to help. So DE is congruent to G, which is over here. And DF is congruent to GF. So DF is congruent to GF like this. And then we are told that angle D is congruent to angle G over here. And then we're told that angle DFE, that's this one here, is congruent to angle GFE over here. So we got this one over here. Now that's going to be pretty easy. Now we're asked to prove that these two triangles are congruent. Okay, well, two triangles are congruent if all of their corresponding sides and corresponding angles are congruent. So, okay, how do we go about doing that? Well, first, when in doubt, let's start out of proof by writing our two columns over here. They're kind of two columns. I'm going to draw the two columns. If you remember, in the two column proofs, on this side we have statements, and on this side we have reasons for our statements, right? So let's start off. So when in doubt, when you don't know, just write down the given information. So if you're given the segment DE, that's what that little thing means on the top. The segment DE is congruent to segment GE, like this, and segment DF is congruent to segment GF, like that, and angle D is congruent to angle G, like this, and we're told that angle DFE is congruent to angle GFE, and all of that was given information. Okay, so that's cool. We got a lot. So one thing I've noticed is when you're given information, and you're given a figure, just mark the figure and make your life easy. Don't try to do it on your head. So to prove two triangles to be congruent, though, we need all sides to be congruent and all corresponding sides and all corresponding angles to be congruent. Well, we know that this angle right here is going to be congruent to this angle over here because of just the theorem that we just learned, the third angle theorem. So that's from the third angle theorem. So very good. We can write that one over here. So we have angle DEF is congruent to angle, so that's DEF, right? So GEF, angle GEF. That's because of the third angle theorem. Okay, so that third angle theorem states, now if you were to say that, and now you just write the whole thing. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. We just third angle theorem. Okay, so we got that. But so we got all the angles are congruent, and we got two sides to be congruent. We need a third side, but this third side is shared between the two triangles, right? So that's a common side. So EF is common to them. EF is congruent to EF. We have to say that because we're going to need the three sides of a triangle, right? So that's actually reflexive property. Reflexive property of congruent segments, isn't it? Okay, so reflexive property. Now we have three sides all congruent. Now we have three angles are congruent. Then we can say the two triangles are congruent. Now we can say triangle DEF is congruent to triangle GEF. Darn it, because of definition of congruent triangles. Definition of congruent triangles. Two triangles are congruent means that all the corresponding sides and all the corresponding angles are congruent. So we proved that these two triangles are congruent. So we listed all the given information. We used the third angle theorem here to say the third angle is congruent, and then we had a side that was shared between the two triangles, so we put that there. So we have all the sides congruent, all the angles are congruent. Then we can use the definition of congruent triangles to prove that these two triangles are congruent. That wasn't so bad. All right, so let's see our last example. Okay, so here's the question. Given information. Okay, cool. It looks like a lot of given information. Angle J is congruent to angle P. So angle J is congruent to angle P. I see two triangles here. Okay. Segment JK is congruent to segment PM. So JK is congruent to segment PM. I got that. And segment JL is congruent to segment PL. Segment JL is congruent to segment PL, like this. Okay, I got that. And then I'm told point L bisects KM. That's point L here. It bisects segment KM. Now that means that it divides the segment into two equal parts, like this. There you go. Ta-da! Now I got that. So I got all three sides to be congruent. Now I'm asked to prove that these two triangles are congruent. Triangle JLK is congruent to triangle PLM. So that's what I'm asked to prove. So to prove these two triangles congruent, I need to prove that all the sides are congruent and all the corresponding angles are congruent. I got all the sides. Very good. And I was very bright. I figured out what the definition of bisect means. So point bisects a segment, divides a segment into two congruent segments. I got that. But I need to get some angles congruent. I got to get some angles. Ooh, watch this. This angle is congruent to this angle, right? Because it's vertical angles. Oh, great. I got those two going for me. How about the last two remaining angles? Well, they're going to be congruent, right? So they're going to be congruent because of the third angle theorem. There we go. We got three angles and three sides. We are ready. Okay, so here we go. Let's write down what we're given. So the given information was angle J is congruent to angle P, and segment JK was congruent to segment PM, and we were given that JL is congruent to PL, like this. This was all given information. Now I didn't put this one over here. I'm going to put that in the next one just because I'm going to use it. See, then I say L bisects KM. You could put this in step 1 too, that's okay, but I just choose to do it separately because I'm going to use it in the next step. See, so in step 3 would be, since it bisects it, I'm going to say KL is congruent to ML, like this. So KL is congruent to ML because of definition of a segment bisector. Okay, so, or midpoint, that's cool. So that we got it. So that's a midpoint. It bisects the segment into two. Then I said I got these two vertical angles, right? So I put the vertical angles. So I say angle JLK is congruent to angle JLK is congruent to angle PLM, and because all vertical angles are congruent, we proved that before. So all vertical angles are congruent. You got to know these theorems, right? All vertical angles are congruent. And then I used the third angle theorem, right? So I can say that over here. So angle K is congruent to angle M, and that was because third angle theorem. That is, if two angles of a triangle are congruent to two angles of a second triangle, then the third angles are congruent. Okay, so we got our three sides, we got the three angles congruent, and then we can say step number 6 that triangle JLK is congruent to triangle PLM, and that's because of definition of congruent triangles. Ta-da! So that wasn't so bad. So in this section, we learned what it means for two figures or two triangles to be congruent, and what we did was we used that information to practice about corresponding sides, because we know that corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. And we learned the third angle theorem, and we used that theorem to do a couple of cool proofs about triangles. Until next time, assalatu wassalamu ala rasulillah walhamdulillah rabbil alameen. Assalamu alaikum.